Hello, and welcome to this AWS webinar. My name is Ian Massingham. I'm a technical evangelist with Amazon Web Services located in Europe. I'm going to be hosting this session for you today. And this session is the second in our 3-webinar series for getting started with AWS. In the last episode a week ago, we introduced the AWS Cloud and talked a little bit about what some of AWS's services are. Today we're going to move on from that and we're going to discuss some best practices for getting started with AWS in this session. As usual, there are materials available for download. You can find those in the Files panel of the webinar interface if you're watching us live, or if you're watching on demand, check out the link in the description of the YouTube video. Also, if you're watching live, you can also submit us questions which we'll answer either live during the session today, at the end of the session verbally, or follow up on in an email from our solutions architecture team here at AWS. So please do ask us questions. So we've got a team on standby to make sure that you get the answers that you want. And if you don't feel that you do get the answer on the first attempt, please do let us have an email or a follow-up and we'll work with you to make sure we get you the information that you need. At the end of the session today, I'm going to show you some social media links that you can use to stay up to date with AWS webinars and actually other AWS events and news as well. So be ready at the end of the session with your Twitter account maybe to follow us on social media. And also at the end of the session, you'll have an opportunity to rate the session and provide some feedback. Really appreciate it if you could let us know how we're doing in this program. And you'll be see at the end of the session that we'll switch the webinar into a Q&A mode, which will also introduce and show to you a rating panel where you can score us from 1 to 5, with 5 being the best. So really appreciate your feedback on the session today. Let us know how we're doing, please, and of course how we can improve things most importantly. Okay, so let's get started with the content for today's session. This is going to be a relatively short session today. There are 3 content items that we're going to cover. The first, very quickly, we're going to discuss getting started with AWS and talk about some resources that you can make use of, which will guide you through the process, for example, of creating an AWS account, launching a virtual machine and some other common tasks. So we'll show you that very quickly. We'll then move on to the bulk of today's session, which is about 8 best practices you should focus on when getting started with AWS. So I'm going to take a quick tour of those 8 best practices, talking about each of them in turn, and introducing some resources and some concepts and some ideas that you might want to bear in mind when you're getting started with AWS to maximize the value that you get out of those first early steps. And then thirdly, very quickly, also at the end, we're going to show you some resources, some links actually, that you can follow to learn more about some of the topics that we're going to cover during today's session. Okay, so let's get started with getting started with AWS. And the main thing I want to do here is just give you a pointer to a really important part of the AWS website. You can see a URL at the bottom right of the screen here, aws.amazon.com/getting-started. And if you visit that, you'll find the Getting Started Resource Center, and you can see a screenshot on the slide here which covers part of that. It will walk you through things like creating an AWS account. It will take you through a short walkthrough of how to launch a virtual machine, how to store media and files, as well as further information about some of the concepts and services behind and provided by Amazon Web Services. And I really would like to encourage you, if you're a new user, please spend 5 minutes after you've watched the session today to bookmark that link and visit us and use the resources that are available there. They're intended as an introduction for new users, and I think you'll find them a really useful resource for just getting you started from the very ground level with AWS services. We'd like to encourage you to do that. So let's move on and take a look at these 8 areas of best practice. And the first is about choosing your first use case. This is maybe surprisingly something that can have quite a big impact on whether or not your first experience with AWS is a successful one. And the guidance that I always give to customers here is to make your first project a smart one. So think about the way in which you might set goals if you're a manager, or set goals if you're a contributor in your organization. You're probably using this acronym: specific, measurable, achievable, realistic, and time-bound. And I think that this applies really well to selecting the first use case, the first project that you might deploy within the AWS Cloud. Be specific, so set clear goals and target a specific project or goal or use case that you want to work on. Make sure it's measurable, so understand when you will claim success and use metrics to help you define that. Do something that's achievable, so specify a goal which is reachable for that first project, and realistic, so one that can realistically be achieved. Don't attempt to boil the ocean or eat an elephant in one bite in your first project. Make it something which you could call, a quick win, something that you can quickly assess whether or not you've been successful at and move on to the next project. And when I say quickly, that also talks to time bound. You want to understand the timescales and how long you're going to give yourself to achieve this first goal that you're going to set yourself in working with AWS. So that's a really important, I think, useful piece of guidance. Don't try and boil the ocean at day one. Start with something small and make sure that first project has a good set of success criteria coupled with it, so you can establish whether or not you've been successful and maybe tweak or tune what you're doing if you want to improve the level of success that you've had following that first project. And there are 4 common use cases that we see customers deploying with AWS as their first project, which are broadly successful. And those 4 use cases are as follows. The first is development and test. It's a super use case to start with because by definition, you're working with non-production workloads. So if you have a few experiences of learning it with this first project, if it's a dev and test project, that's unlikely to be visible to your end users. And it's a great idea to learn how to work with the AWS Cloud with non-production use cases. There are also some natural characteristics of the cloud which are really well aligned with dev and test workloads. Things like the fact that you can spin up and down environments on demand, and you can decouple development and test environments from some of the normal operational constraints. The fact that you might not have enough environments when you need them, for example. Those are things which are very easy to overcome with the AWS Cloud. You can find that a lot of financial and other benefits from running dev and test workloads in AWS. And this is something that we'll return to quite soon in our other webinar series, The Journey Through the Cloud, where we talk specifically about some of the benefits and practices that you might use when running dev and test workloads on AWS. That's a very common first use case. We really encourage customers to take a look at that as a first use case because it's a great way, as I've said, to learn about AWS with non-production workloads. Similarly, backup and DR, once again, you're working with non-production workloads here, non-production data, but obviously there is an area of criticality if you need to restore from a backup or invoke your DR. And you can take your data or business applications step by step from non-production into production as part of your DR testing process. So once again, it can provide a useful framework within which you can learn about the AWS cloud, and you can understand the dynamics of the cloud and test them carefully during that controlled failover process. So backup and DR is also a very common first use case that customers will look to. Thirdly, greenfield projects. So if you're developing or deploying a new application or a new workload, it's helpful often to start with a blank sheet of paper, and the cloud certainly gives you an opportunity to do that. You can build your architecture from scratch and embody some of the best practices for cloud computing in these unconstrained projects. And of course, you can tear down that architecture and rebuild it as necessary if you're using AWS at very, very low cost and with very minimal impact. So greenfield projects can also be a good way to get started with the AWS cloud. And this can take the form quite often of self-contained web applications, storage intensive projects like document archiving and the like. So take a look at greenfield projects. And then lastly, you might have a specific pain point that you want to focus on. You might have a specific service which is causing undue cost or heavy management overhead. And by using the cloud, applying the AWS cloud to those challenges, you may be able to solve that. And some of the things we see here quite often are processing workloads, search indexing, media streaming, archiving once again popping up here. So that's a third use case that you might want to think about, a third class of use case that you might want to think about when trying to identify the first project that you're going to deploy on the AWS cloud. And once you've got that first project identified, you need to think about the life cycle. We often see customers move through this common life cycle when they're deploying that first project and working with it, starting with a proof of concept, understanding the specific AWS services that they're going to apply to this use case, testing for performance, architecting for scale, and importantly, developing the capabilities and skills of the team, whether that's in-house or working with an AWS consulting partner to help with that proof of concept project. And that can help you familiarize yourself and familiarize your team with the way in which AWS operates, of course, and how your workloads will be deployed and managed inside the AWS cloud. Once you've done that, you may move into production with that workload, implementing things like monitoring, improving your control framework around change control and management, your ongoing security operations management framework, and of course, working to scale that service up. And once you've stabilized in production, you can then move to the automation phase of this life cycle, looking to automate corrective actions, implementing auto scaling, working with continuous or zero downtime deployments, making sure that your system backup and recovery procedures are slick and work very effectively. So we mostly see customers move through the life cycle in this kind of manner. That's all about workload selection and what that project evolution is going to be. So number 2 in this list of 8 best practices is to think about the foundations that you're going to be working with. There are 4 components to this. The first is account structure. So there's nothing to stop you, and in fact in some circumstances we would encourage you to create multiple AWS accounts. You can use accounts like environments where you might need separation, maybe separation of duties, maybe you want to restrict the span of control individual users have. So you might create an account for your development environment, another one for test. You might create an account for each business unit that you have in production. You might create accounts orientated around individual products or services that you're going to support on the AWS Cloud. That's very common, and you need to create an account structure that makes sense for you, and have a think about that before you start. You know, what are the business units, what are the environments, what are the products or services that you want to support with the AWS Cloud over the medium and long term, and how you're going to map that into the account structure that you're going to create. This is also important from a billing perspective. You can do something called consolidated billing, which we're going to talk about later in this section. It's a very powerful feature of AWS. It allows you to have multiple separate accounts, but let one account pick up the bill for those multiple sub-accounts. And you can use that as a mechanism for exercising cost control and improving the granularity of cost reporting, something that's actually quite difficult to do with traditional on-premises resources, where you may have to arbitrarily allocate capital resources to individual business units or projects. Quite tricky to do that. There's a helpful feature of AWS that makes that very simple, which we'll talk about in just a couple of moments. So think about that billing as well, and think about how you're going to structure billing, mapping your cost controls across to the organizational units or accounts that you're going to set up. One thing you can do here is to set up delivery of billing reports. This is a really powerful feature, and if you look on your AWS console, visit the billing and account management section, which you can find from the drop downs on the right hand side, top right hand side of your console, and then visit your billing preferences, and you can turn on here enable delivery of billing reports with resources and tags. This is how you can get granular information about how your AWS services are being consumed. You can make use of these resources and tags to provide metadata about your AWS services, or rather to record metadata about your AWS service usage. And then you can report on that. And that looks a little bit like this. So you'll have a master account, which you're going to use for billing. This is where we're going to consolidate our billing data from our sub-accounts. And what we've done here is to create a specific email address for our AWS resources within our company. This is helpful because obviously it means that if an individual leaves the company that might be responsible for billing, you can redirect that alias elsewhere, or maybe have that alias go to a list of individuals within the company that hold responsibility for payments. So that's a very good idea to do at day one. Once you've got that master account, you can then create sub-accounts, linking them together through this consolidated billing relationship. And each one of those sub-accounts can have its own administrator and its own administrative namespace in the form of these IAM users, and we'll talk more extensively about what IAM is, Identity and Access Management is, later in the course of the session today. Once you've got your sub-accounts set up, you can then start to make use of tags. Now tags, they're key value pairs, metadata, that you can associate to AWS resources within each account. And by setting an appropriate tagging schema or scheme and using that across a variety of different sub-accounts, you can analyze and report upon the usage of AWS resources across the different accounts that you're operating, aggregating this at the top level and using it to determine where your bills are being generated. In other words, who is consuming AWS resources and how much spend they are accruing as a result of that. This is a really good idea to do this. So different administrators per sub-account, different management namespaces in those separate IAM namespaces, but the same tagging scheme across different accounts to enable you to consolidate your costs together for cost reporting purposes. That's something I really recommend doing. The other thing that you can do within the different accounts is you can set up different spend alarms. This uses an AWS service called CloudWatch. Inside CloudWatch you have metrics, and you can put, or rather trigger, alarms when those metrics pass certain thresholds. And one of the metrics that you can report upon is estimated spend. So you can set an alert for estimated spend in your 3 different accounts, which would trigger an email to your account administrator in each sub-account and let them know that they've passed a particular spend threshold. You can have multiple spend thresholds per account, many metrics as you want. So that's a really good way for helping you to control your bill or have visibility of your bill intra-month, and preventing cost overruns, of course, is another helpful benefit that you'll derive if you implement that. So I recommend doing that as well. In the master account, by virtue of turning on those billing reports, you get programmatic billing access. And what this does is deposits CSV files into a specified S3 bucket. And you can use those CSV files for analysis. You can see, for example, here, you can identify the owners or the stacks that are being used by applying metadata tags that contain this data to each resource that you can create. And you can use that to slice and analyze the total cost that you're incurring through your usage of AWS. There are also a variety of third-party cost management tools available to you. You can see 3 examples here: Cloudability, Cloud Checker and Cloudin. And these are third-party tools that will take those billing data files that I talked about creating a second ago through that programmatic billing access, and they will analyze those with some very sophisticated cost analysis, reporting, even optimization tools that they have. I really would recommend taking a look at these partners, this ecosystem of cost management partners. If you think that you're going to incur anything like significant spend on AWS, they will give you enhanced visibility and also allow you to do some modeling, cost optimization that will be helpful to you over the long term. Many of these partners have free trials. I really would, once again, like to encourage you to take a look at them and see if they could offer value in your particular use case. Just 3 examples, many more available in the AWS partner ecosystem. You can find that at awsamazon.com/partners. And if you look in the technology partner section there, you'll find many more partners that are operating in this space of providing cost management and analysis services to customers. So there's lots in the third-party ecosystem as well. Moving on from accounts and billing, 2 other areas that you need to focus on in this foundational stage. Thinking about your access keys. So these are keys that you will use to access your EC2 instances, should you create them in your account, via SSH or via the process of encrypting and decrypting the administrator password on any Windows instances that you might create. And you'll can create as many of these EC2 key pairs as you wish. So you need to think about how you're going to separate access, maybe separate roles by using different public-private key pairs, by rotating keys, and maybe using Bootstrap automation to grant developer access with unique key pairs. All things that you can consider at this stage, thinking about your key management strategy. And then lastly, groups and roles. So you can use these identity and access management groups to manage console users and API access, setting up a group hierarchy, assigning permissions to groups, and then placing users in those groups is a much simplified way of managing who can do what within your AWS account. There's also a IAM construct known as IAM roles that allows AWS to manage API access credentials for instances, so granting system entitlements to make use of AWS resources. It's an abstract concept, I guess, for those of you that might be new to AWS, but it's a very powerful tool. You have an account. Within that account, you have groups, and within those groups, you can assign users or add users, doing things like restricting access using multi-factor authentication and attaching usage policies to those users to give them or deny them access to specific sets of AWS resources. You also have these roles. Once again, you can assign credentials to these roles, and those are system credentials that allow EC2 instances or other AWS services to interact with the AWS APIs. For example, accessing an S3 bucket or starting additional EC2 instances could be something that you grant a role for, then able to do that programmatically from a system or using code that you might develop using the AWS SDKs. It's a very, very powerful tool. And you attach policies to these groups or roles. This is an example policy here, a very simple one, which just allows a particular group or role to work with only a subset of AWS services. So you could see that if you attach this policy to a group, users within that group would only be able to work with the AWS services that are listed there. Policies are created using JSON and they control access to the AWS APIs. Now it's a deep subject. We could probably spend, and in fact later in the year, we'll spend pretty much an hour talking solely about IAM. Because it's a very powerful and deeply featured service. But for the purposes of this session, if you want to learn more about that, I'd advise that you visit aws.amazon.com/IAM and take a look at the product documentation that's available there. It'll give you a good grounding in the way in which you can use user credentials, groups, and roles to manage permissions within your AWS account and make sure that you have the right security posture. Moving on from that to talk more generally about security, which is the third area that we're going to focus on today. AWS operates what we call a shared security responsibility model. Okay, because you're building systems on top of the AWS Cloud infrastructure, the security responsibilities will be shared. AWS, we've secured the underlying infrastructure, but you must secure anything that you put on the infrastructure or connect to it. And for infrastructure as a service services like EC2 or S3, you have more control and therefore you have more configuration work to do. So for example, with EC2 instances, you're responsible for patching the guest OS on an instance once you've created it. You're also responsible for things like configuring security groups. These are akin to software firewalls that permit outside access to your instances, or setting up the VPC, the virtual private cloud subnet that your instance is going to reside within. Similarly with S3, you have to set control policies to permit access to S3 buckets that you might be creating. Moving a little bit up the stack a little bit, with platform services like RDS or Amazon Redshift, our petabyte scale data warehouse service, you have less security configuration to do. You don't have to worry about launching or maintaining instances or patching the guest OS or applications. We would do that for you. But you do still need to manage things like security groups to permit access to those RDS instances or to those Redshift data warehouses from other AWS instances that you might be running. There are certain AWS security features like IAM that we've just talked about, which are account wide, and you do have to configure those no matter which AWS service you're going to use. So security is a very, very important area for the vast majority of customers. In fact, a top priority really for the vast majority of customers. And I just want to share with you some good practice that we've seen customers use to help them deploy or migrate applications to AWS in a secure manner that meets their needs. And the first area to talk about is about understanding your customer and determining your security stance. So you can see here that you have an external audience that you might have to work with, namely your customers or stakeholders within your business. And from that perspective, you need to focus on the certifications that you need, the security management processes that you're going to use, things like penetration testing to validate the security practices and processes that you might have put in place. But that is supported, hence the drawing here really, supported by an internal audience and a regulatory audience that you need to work with. So things like the architecture that you use to ensure that you have security by design, the administration of the services that you're using to ensure that they are managed and controlled in a secure manner. This will lead you to use tools ultimately like IAM, just as one example of a tool that you might use to satisfy that administration requirement. On the other side, maybe less hands-on technical, but still quite technical in nature, the regulatory audience. So this is where things like security certifications, white papers, and the QSA process become important. So these are things that AWS can help you with. We have done a lot of work to ensure that we meet the highest security standards. But having said that, security assessments still take time. So it's important to allow for this in your planning cycle and to undertake architecture reviews early in your design and deployment process. And we find that customers that follow these good practices, making use of things like AWS's ISO 27001 accreditation, our PCI DSS Level 1 Service Provider accreditation. There's nothing to fear in achieving the right level of security accreditation. You just need to work with the accreditors in the way that many thousands of our customers have already done, and make sure that you get that up front in your design and deployment process. And some of the resources that are available for you to help you do this. Well, the first thing to say is there's comprehensive documentation about AWS security practices and processes at awsamazon.com/security. And if you go there, visit that location on the AWS website, you'll find a lot of resources. Things like the Risk and Compliance White Paper, the AWS Security Processes White Paper, details of how you can get access to the consensus assessments that AWS has completed for prior security audits. Those are available under a customer NDA. So take a look at the documentation there if you're running any kind of security critical workload in AWS. Make contact with us using the processes there to get access to the resources that you need. Many of the resources are self-serve, but some of them you need to contact us for. Obviously, very happy to work with you and help you achieve whatever security accreditation you need. And lastly, build upon the security features of AWS to implement security by design. We've obviously got many customers that are using Amazon Web Services today to run security critical workloads. And there's a helpful sort of characteristic of the cloud here, which I call the highest common denominator feature, which is that whenever a demanding customer requests a particular uptick in our security processes or asks for another service or feature that will help them implement or validate their security stance on AWS, the nature of our platform means that becomes available to all customers that are using Amazon Web Services. This has led really to some great innovations in the area of security and control, things like IAM, which we talked about already, enabling you to implement this tiered access model. Having separation between the APIs that control AWS services and the public-private keys that are used for instance logon, for example, enabling separation of roles between administrators, operations personnel and developers, and also things like the ability to create temporary API credentials that you might need for permitting untrusted devices to access the AWS APIs for a short period of time. Maybe if you're rolling out or deploying mobile applications in AWS, you may make use of that. Control and audit, instance firewall security groups we touched upon already, but we've got other services like AWS Cloud Trail and AWS Config that allow you to record and audit access to AWS APIs or record and audit configuration changes within your environment. Very helpful security management tools, and again, tools that it's quite hard to replicate in a traditional on-premises data center or private data center environment. The use of the VPC, the virtual private cloud, things like subnet control, creation of bastion hosts which might be restricted and not operated when not needed for access. Their startup being restricted by multi-factor authentication by MFA. So you can build a very strong security posture with use of that kind of technique. And things like VPC peering, enabling private connectivity to other VPCs, peering your VPCs together, allowing you to share resources across multiple networks owned by you or other AWS accounts. All of this innovation has been driven principally by customers asking us to implement these features. So it's very customer directed development. And then lastly, direct connect and VPN access. So you can create secure private network connectivity from your network or point of presence on your wide area network and build that into AWS using either direct connect, which is a private high bandwidth low latency network connection directly from you into the AWS cloud, or over a VPN service where the endpoint is provisioned for you and you can control traffic routing from that VPN in and out of your VPC using your own defined routing table. So a very powerful set of security features that you can build on top of in order to make sure that you build the right security posture for your particular application or workload. And in a similar vein, building on the strengths of the AWS cloud more generally, this is also something that we encourage customers to think about before starting to deploy applications inside the AWS cloud or migrate applications to the AWS cloud. And there's some obvious strengths of the cloud. The fact that you can support variable capacity requirements, you can quickly and repeatably create standard technology stacks or defined reference architectures. So review your application architectures early and see if you can make use of any of those characteristics from day one. There are also services that can be plugged in, if you like, into pre-existing architectures that you may have that might enable you to reduce costs or improve reliability with a really minimal level of effort, a really minimal level of outlay. Things like Amazon S3 and CloudFront, you can use that to deliver static content that might be required for your public applications, and to do that in a very, very cost-effective and easy to configure way. Thirdly, there's an opportunity in many cases for the cloud to help improve business performance more generally, helping you deliver products more quickly if you're an organization that relies heavily on software development, maybe reducing the capex that you need for IT or boosting your agility. You can reinvest that money in other activities that your organization might get more value from because you're not having to spend it on IT anymore. And this is something that we see many customers do sometime into their usage of AWS, rebalancing their investment and spending less money on IT overall, of course. The earlier you look at that in your process and your deployment cycle, the more quickly you can deliver those benefits to your organizations. That's also something we really encourage customers to take a look at. And then fourthly, opportunities that you might have to deliver more robust services or services that are more agile or more secure, making use and adopting automation throughout the life cycle of your applications, using things like fully scripted deployments, using IAM and EC2 instance roles to improve your security posture, or rolling or continuous deployment techniques. Again, things that customers often turn to after they've been using AWS for a little bit of time. We really like to encourage customers to look at that early and establish whether or not you can take those strengths of the cloud and get value out of them for your organization as quickly as possible. And looking at a few different dimensions here, really, 4 areas that customers can focus on, and customers do focus on to deliver these benefits. Things like disposable compute, designing systems that can tolerate instance failures. Also helps you dispose of compute when it's not required, so your costs are going to be more elastic as a result of that, and they will more accurately track the level of demand that you might have for your application. So think about disposable compute. Think about the flexible nature of capacity in the cloud, the fact that you can design systems that can dynamically scale from 0 to hundreds or thousands of instances, and you can use a variety of different events to drive that, auto-scaling with events or schedules or triggers to drive capacity availability so that it accurately matches the amount of demand that you have. You can cost optimize by using the cost-effective storage options that are available to you within Amazon Web Services, things like S3 for durable and cost-effective storage of data and objects, and also other techniques like using RDS or DynamoDB to provision and scale the persistent storage that might be required for your application, whether that's relational or non-relational database storage. Once again, very cost-effective way to deliver that. And lastly, automation and control. Automating everything from deployment to scaling to instance recovery from failure can dramatically reduce the amount of resource that has to be devoted to operations, and can also help you build applications and services that are robust and recover from failure with little or no human intervention. So who doesn't like to avoid being called at 2 a.m. to fix an application? That's something that you can resolve and automate using some of the features that are inherent within the AWS platform. Just on the deployment side of this and the scaling side of it as well, the techniques for bootstrapping that are available for you. So this is getting your computing resources specifically into a state where they're ready to start supporting your application. There's a couple of different approaches that are available to you here. One is bootstrapping with custom armies. So armies, Amazon Machine Images, the baseline images that are used from which you create instances which you're going to run within EC2. The process for this really is that you create an instance for your operating system choice. You then configure your environment, install software that you might need. You can then snapshot that instance and create an army from that snapshot, and that enables you to launch a fully configured instance from that army, and to do so very rapidly and in whatever volume you require. And this is a technique that can be used to enable auto-scaling or programmatic deployment of resources. So one of the options that's available to you, use of custom armies. The second is bootstrapping through the use of the metadata service. So this is configure on startup. The metadata service, it contains and provides information about a running instance, and it's specific to the particular instance. So accessing that API on different instances will give you different data, even though you're going to access the same, on the face of it, the same API. It's actually private to the specific instance that it's accessed from. And you can use that to gather information about your instance, things like the ID of the army that might have been used to launch it, the profile that you're using, the public host name of the instance, etc. You can also embed user data in this metadata service, and that user data can contain scripts which will be executed on launch, and you can use this to perform programmatic configuration of your instances at startup time. You can use this on the Linux platform with shell script or on the Windows platform with PowerShell, so available across platforms. You're receiving this custom data and you use that to drive bootstrapping. You can obviously do a variety of different things with this, things like installing software, pulling application or data packages from S3. You may be publishing metadata for this instance into another system, for example, to register with a monitoring system that you might be using, or to register as part of a cluster that can be executed via this bootstrapping process, and also to set up the security profile of an instance, for example, determining whether or not your production or development instance, and maybe configuring yourself in a certain way on the basis of that piece of metadata. That's also open to you as an option. Next thing we're going to do is take a look at making use of some of the availability constructs that are available within AWS in your architecture. The first thing to say is AWS regions, as you may know, are distributed, split into separate logical availability zones. And each one of these availability zones comprises at least one physical facility or at least one physical data center. So by distributing your application across availability zones, you're making use of more than one physical data center to support your application. And that is a way that you can architect for availability inside the AWS Cloud. Many of the services that we provide are are aware of this availability zone construct. Things like RDS, you can specify masters and slaves that are going to be distributed in different availability zones for you. You can also specify the distribution of read replicas across availability zones to help boost the performance of relational databases that are running inside the RDS service. And of course, you can also distribute your EC2 instances across these availability zones as well. So use RDS with replicas and slaves, and not only will your compute capacity be distributed across AZs, but so will your data, your persistent data. You can then use auto-scaling groups to provision and deprovision compute capacity as you need it for your application on the basis of metrics. And auto-scaling itself is aware of the availability zone construct and will seek to balance your resources across the availability zones that you configure. And you can see here we would be adding our instances in pairs, one in each of the availability zones that's been configured with this particular auto-scaling group. And we can use elastic load balancing, the ELB service, to distribute incoming traffic across those auto-scaled instances. And that again is a regional service which is aware of availability zones and can distribute traffic across them. And then on the inbound, we can use Route 53 to host our DNS zones, ensuring that the front door to our application, in essence, is always available. Very, very reliable service with extremely good availability characteristics, very, very good performance on the resolver. And that will bring traffic to our load balancer, from where it will be distributed across our AZs, hit our web server tier, and make use of that database, which again is distributed across those AZs. So just to recap, building on the strength of the AWS Cloud, make use of services like elastic load balancing. Just described there how you can use that to distribute traffic across your availability zones. Route 53 for inbound traffic. It's got some sophisticated features, mostly reliability and high performance, but also sophisticated features like weighted routing, the ability to control TTLs and DNS updates, and also to integrate with other AWS services like the elastic load balancer. Make use of RDS, and you can scale your databases without the admin overhead that you might normally associate with running relational databases on private infrastructure. And it's very simple with AWS to add features like high availability or data replication, creating master and slave configurations with data replication between those availability zones that we talked about just a second ago. Lastly, auto-scaling. So this enables you to dynamically scale resources, and by doing that to more accurately match the amount of capacity that you have to the amount of demand that you're seeing for your applications, and therefore control costs by doing that. So those are the 4 areas of strength that we talked about during the session today. For more details, visit the AWS Architecture Center at awsamazon.com/architecture. You can find a lot more detail about some of these areas of good practice, as well as a large library of architectural best practices and templates that have been developed from our work with other AWS customers around the world. And I really would encourage you to take a look at that before you deploy anything substantive in the AWS cloud. You may find that we've already worked out an architectural model that can be used to support your specific application. So awsamazon.com/architecture if you want to take a look at that. The 5th area of focus we're going to talk about is services, not software. And this really goes to the core of something that I often talk about when I'm discussing the AWS cloud with new customers that might not use the cloud today. And that is that getting maximum value out of AWS is quite often has a little bit to do with not doing things, or maybe more accurately, stopping doing things that you might have done before. So with a traditional self-service managed software and infrastructure stack, you spend a lot of time actually doing things which aren't particularly differentiating, whether that's building data centers, installing servers, or maintaining the software that you've got installed to deliver the features and applications that your business relies upon. A lot of that is not actually particularly value adding. And by using the AWS cloud, you can get away from a lot of that, stopping a lot of that undifferentiated heavy lifting, spending a small amount of time configuring the services that you want to consume from the AWS cloud. This can free up time for you to focus more of your time on things that are value adding and do genuinely differentiate your business. So stop doing things if you're going to use AWS and think about how you can use that time more productively to deliver more value to your organization. And some examples of services, some of which we've already talked about, that you might want to consider in order to achieve that goal of doing less and differentiate heavy lifting. Well, things like RDS, the relational database service for relational data sources, or Amazon DynamoDB, our non-relational NoSQL database service with its fast, predictable performance and support for document and key value data models. Both tools or services that you can use that will deliver functions that are likely to be required by the applications that you're running without you having to focus on operating the platform, maintaining the platform, scaling the platform, recovering the platform in the way that you would traditionally have had to do with on-premises or private dedicated IT. So I would like to just encourage you to take a look at AWS services in that light and work out if there are opportunities for you to stop doing things. There are other services as well, like the Simple Queuing service or Amazon EMR, our Elastic MapReduce service for running Hadoop workloads in the AWS cloud, and others like Amazon Kinesis, some of the mobile services that we've recently announced, Amazon Redshift, where you can make use of services that will simply reduce the amount that you have to do in order to build and operate the applications that you and your organization need. So please spend some time, familiarize yourself with the breadth of AWS services and check out what opportunities you've got to do less. Sixthly, cost optimization. We're not going to cover this in a huge amount of depth during the session today, because we have another webinar coming up next week where we're going to spend 45 minutes to an hour talking solely about cost optimization on AWS. And in that session next week, we're going to be covering these 10 topics really: how you can use the right instance types, use auto-scaling, turn off or shut down unused instances or other services that you might be making use of, purchasing models that are available to you like reserved instances and spot, the use of storage classes, the use of offload, moving parts of your workload to AWS services like CloudFront, use of services, not software. Again, we're going to revisit that with some examples of ways in which you can save money by doing that. Use of consolidated billing to aggregate together your demand, and use of cost management tools to give visibility and insight into your costs. So that's going to be the outline agenda really for the session that we're going to have next week, where we focus on cost optimization. But just to whet your appetite and give you a bit of a teaser, for example, on using the right instance type, again, we covered this actually very briefly in last week's session as well. We have a broad range of different instance families, things like the general purpose M3 series instances, the new compute optimized C4, GPU enabled G2 instances, memory optimized R3 instances, as well as storage and I/O optimized instances. And it's important to dimension the instance that you're going to use around the workload that you have. So if you're running let's say you're running a large non-relational database, and rather than using DynamoDB, you're running that on EC2 instances, it's likely to be either a memory or I/O intensive workload, depending upon the nature of the database that you're running and its size. And you should dimension your instances appropriately. Make sure you're running on an instance that offers the best price characteristics for the resource that you need most of. So if it's memory, then make sure you're running your workload on an R3. You will pay less per gigabyte of RAM than you will on any other instance family. So that assessment is an important activity to conduct when you're getting started with the new application on AWS to make sure that you're minimizing your bill. Another technique that you've got for minimizing cost is to use different instance purchasing options, on-demand, reserved, and spot instances, and we'll talk about this in much more detail in next week's session. But there are 3 ways in which you can buy EC2 instances with different economic characteristics that fit different use cases, whether that's on-demand for those short-term, spiky or unpredictable workloads, whether it's reserved instances for long-term workloads where you might want to reserve capacity over a 1 or 3 year period, or whether it's spot. You might be running high-performance computing workloads, supercomputers in the AWS Cloud, and the spot market is a great way to acquire the compute capacity that you need for that at very low cost. So options that you have around how you buy your instances can have a significant effect on how much they cost, and you should be aware of that. If you want to learn more about that ahead of next week's session, then visit the EC2 purchasing options page that you can see at the bottom of the slide there, and it'll give you more detail on those 3 different purchasing options and how they will affect the amount that you pay for your computing capacity with AWS. Number 7 to look at is tools and frameworks. This is a very broad area, very interesting area to look at. Maybe the foundation to start from really is to consider that everything is programmable with AWS. You can access everything via the CLI, via the APIs, or via the console that we have. And the console, in fact, is built on top of the API itself. You can use one of 9 today, soon to be 10, with the announcement of upcoming support for the Go programming language SDK. And you can use those SDKs to create or make use of AWS resources within your own code, within software that you develop. You can make use of this broad ecosystem of tools, open source, free and commercially licensed tools to work with AWS services, things like community contributed SDKs for the languages that we might not support, things like automation frameworks that might make use or be integrated with AWS, things like Ansible or Puppet that might be able to provision AWS resources using plugins that have been developed and make use of those SDKs. So a very, very comprehensive ecosystem for automating deployment, management and control of AWS services, and also working with AWS services as primitives within other software. And by combining these things, you can build or deploy the highest levels of automation, define your infrastructure as code, support continuous deployment, or automate other development ops or DevOps processes. So there's an awful lot you can do as a result of the programmable nature of the AWS Cloud. And there's a resource there at the bottom, awsamazon.com developers/getting started, which will enable you to download and make use of sample applications that have been built in various programming languages and make use of the SDKs and make use of AWS services within them. So I'd like to encourage you to take a look at that if you're developer minded. In a similar vein, there are also a variety of AWS provided deployment and management tools, things like Elastic Beanstalk, which is a container for running applications of various types inside the AWS Cloud, and removing the requirement really if you have to focus on infrastructure of any type, whether that's EC2 instances or VPCs or RDS instances. Elastic Beanstalk can automate the creation of the resources that you need to run your application, whether that's a piece of PHP code or a Docker container. It supports a variety of different containers for execution. OpsWorks, which enables you to define stacks of AWS resources comprising the layers. Those layers themselves are defined using Chef, a configuration management tool, and executed by OpsWorks, enabling you to dynamically scale your environment in that way. CloudFormation, a more complete templating language actually that allows you to define collections of AWS resource and then programmatically create or destroy the resources defined within a template or set of templates. A very powerful tool used by many sophisticated AWS customers to support continuous deployment, continuous integration on AWS. and a new service called AWS Code Deploy, which is intended to ease the deployment of code onto fleets of running EC2 instances, providing features like roll forward phase deployments with awareness of availability zones, the ability to define precisely what you're going to deploy and how you're going to deploy it using a templating language. It makes it extensible and able to support a wide variety of different application types and deployment models. So you take a look at AWS Code Deploy if you want more information on that service. Those are just a few examples of deployment and management tools from AWS that fit into the broader ecosystem that I described earlier. Finally, then, in our 8 areas of good practice, 8 areas you should focus on as you're getting started with AWS, I wanted to talk about getting supported finally as the last focus area. And there are 4 tiers of support available if you're making use of AWS: basic, developer, business, and enterprise. And you can find out more details about all of these at awsamazon.com/premium support. Basic support is free. Developer costs $75 per month. Business starts at $100 or 10% of your AWS bill, but as your usage scales up, the percentage of charges scales down. There's full details on how the percentage scales down at the URL that you can see on the slide there. And enterprise starts at $15,000 per month and also scales down as your usage increases to 3% with spend of over $1 million per month on AWS services. And as you can see, tiered benefits that are delivered with these different support packages. Business support, which I would recommend for the majority of customers actually. You've got a response time of under an hour. You have unlimited users that can submit technical support cases within your organization. That's defined using IAM users. You've got 24-hour technical support access via phone, chat, email, and live screen sharing. Very useful and powerful set of features. You also get access to something called Trusted Advisor with the business and enterprise support tiers. This is a really sophisticated tool actually that programmatically checks the status of your AWS account. It will make recommendations about how you can, for example, optimize your costs, improve performance of your resources, or improve security. There's over 37 checks available at the moment in Trusted Advisor, organized into those 4 categories, and it will make recommendations. You can see here the recommendations around fault tolerance from one of my accounts that I use for demo purposes, and you can see I've got out-of-date EBS snapshots, and I've also got EC2 availability zones that aren't balanced properly. I'm running in that instance actually here in one of my AZs, but I'm not running one in my other availability zone, and I'm being warned about this because I have an imbalance. In other words, if that AZ fails for any reason or is temporarily inaccessible, then my NAT instance will be out of service and I don't have another one to back it up. And you can see the details of that here, as well as recommended actions that are being proposed to me by Trusted Advisor. So really would recommend that customers make use of this service. It's very powerful, and customers that do use it give really positive feedback about how it helps them minimize and mitigate incidents that might occur if they hadn't implemented some of the recommendations of Trusted Advisor. Another maybe less well-known feature of AWS support is that, once again, on the business and enterprise tiers, provide extensive support for third-party software over and above the software that's provided, or rather operates the AWS services. So you can get operating system support, infrastructure software component support for commonly deployed web and database servers, by virtue of having a business or enterprise support subscription. Again, you can find out more details about third-party software support also from that same URL. So there's a range of different support services that are available to you. And like all AWS services, these are commitment-free, so you can take them just for a month or 2 months, establish whether you get value from those support services. If you do, continue. If you do not, then you can cease them with no penalty. So there's nothing to lose, quite literally, by trying AWS support for a couple of months and just establishing whether or not it adds value to your use of the services. Okay, so that's the 8 areas of focus that we were going to look at. I did say I would quickly share with you some resources where you can learn a little bit more about some of the stuff that we've talked about during the session today. We've shared many of these URLs with you already. The Getting Started guide at awsamazon.com/getting-started. the Security Center, the Architecture Center, and details of premium support you can see there. And if you'd like to register and attend the next webinar in this series, which will talk about cost optimization on AWS in a little bit more depth, then visit the campaigns/EMEA-getting-started URL. You can see at the bottom there. And you can register for next week's webinar there as well. And of course, if you want to access the materials from the session today so that you can get access to all of the links in today's presentation without having to copy them all into your browser, just grab a copy of the presentation materials in the PDF from the Files panel. You can then just click the link straight from the slides that you can see. Something else that I just want to quickly touch upon before we close up today. We have a comprehensive set of training and certification offerings at AWS. So if you are interested in pursuing more AWS training or maybe even AWS certification, we have a portfolio of hands-on labs, self-paced labs that you can make use of, formal classroom-based training in the form of instructor-led courses, and a certification program where you can become an AWS certified developer, architect, or systems operations professional. You can find more details about all of those offerings on the slide that you can see here. Okay, so that's all we have for you for today's session in terms of content. I did say I would show you these social media links at the beginning of the session today. So if you are interested in keeping up to date with AWS events, webinars, also in-person events that are running around the UK, and also keeping up with AWS user groups here around the UK, why don't you find us on Twitter at AWS_UKI. Similarly, for AWS service announcements and global news, you can follow us on AWS Cloud, also on Twitter. You can find me at E&M if you're interested in keeping up with the life of an AWS evangelist here in Europe as well. Okay, so that's all the content we have for you today. We're going to turn to a few questions now and put the webinar into Q&A mode. Please stay on the line if you want to ask us any questions, and we'll hang around and answer any questions that you might have. Submit those via the Q&A panel that you can see in the webinar interface. I'd like to thank you for joining us for today's session, and let's take some questions now.